Yeah, it has been started now. Thank you.
Okay, I'm leaving now.
Sure. Thank you. All right. So I'll share my screen and then we can start the discussion. Before that, if there are any specific questions that you'd like to ask, please ask. Uh, we'll be taking that.
Yes, sir, I have one.
You have a doubt?
Yeah, yeah.
Yeah, go on, please.
Week 9 graded assignment, fourth one, sir.
Mhm. Fourth one. Okay. Let me see, please.
Fourth and fifth. Both.
Okay. Okay. Are you able to see this?
Yes, sir.
Okay. Okay. This one is it. Which of the following sets below correspond to the language generated with the given grammar? That is fourth one. So this is in relation to the common data that is given here, right? So let's see this one. It says, given a context-free grammar or a finite alphabet that is sigma, right? So A and B, those are the only two possible letters we have. With the production rule is given like this. So there are two rules, right? So you have this choice. So you can start like this, and then so in this case there is no X. You can see, right? So it could be S or anything like non-terminal symbol. You can consider anything. So in this case we are just considering S. That is perfectly fine. No issues with that. So we can start and directly go to A B also. So that is one production. Right. Or the other case is that we start with S and then go to ASB, and then you have S in between, right? So then you can replace it with another ASB and so on. So I'll just maybe share something like a notepad and then show you how it is done. And otherwise, at the end, maybe we can like select this one so that we can go to AB. So the idea then is that it asks which of the languages is corresponding to this particular grammar that is given, right? So the way to think about it is something like that. So you have S and A, B, right? So in this case, what happens is that you're going to have A and B both, right? It is not possible to like leave out one character because you always have it, right? So if you even if you go with the first rule, let's say rule number one, so you get ASB. In that case, also you have AB, and then you go to the last rule, let's say that is SAB. So in that case, you get AABB, right? That is what you get. So nonetheless, so that's the idea. What happens is that this is the thing that you're going to have because this n is denoting the number of letters that you're going to have. So how many A's you will have? You'll have equal to or greater than one A, of course. And similarly for B, because these are equal, right? Equal number of A's and B's in some sense. So that's how you can think about it. We cannot consider zero because there is no case wherein there is no A or B. It has to. I mean, like it has to be something. It has to be at least once because both rules are having A and B. Right, and therefore option C is correct here. Does that clarify that? Yes.
Yeah, yeah.
Okay, and similarly, continuing on that same common data, what we're doing now is that this AB rule, the second rule, the first rule is still there in place. That is what it says. See, the other rule is retained as it is, which means there were two rules, right? So S to ASB and similarly S to AB. What we're doing to the second rule now, we are just mutating it or changing it. We are making the change such that this B is no longer there. So we can have A, sorry, we can have S A S B, that the first rule, and the second rule is now A S to A. So in this case, what happens is that you can also have one possibility wherein B goes to 0, right? That is still possible, because we can start from S and directly go to A. For instance, if I make that choice, then I only have one A, right? And there is no B. So what will be the count of B in that case? It goes to 0. Therefore, we are having this n greater than equal to 0 also, because B can go to 0. And similarly, what we have done with respect to n, we have added 1 here, n plus 1. So because we are starting with 0, right? So even if you have n as 0, A is going to be 1 in that case, right? Because n plus 1. So A is always going to be 1 more than the number of B's that you're going to have. I mean, that's another way to think about it, right?
Yeah, yeah. Okay, okay. Got
So,
it.
yeah, sure, sure. So any more questions from this one, this particular assignment?
No, no, no. That's,
Okay, you understood that weekly killing and all that, right?
yeah, yeah.
Strongly, yeah, sure, sure. Okay, so that's what we have. So let me just quickly go to the other one. Let me stop sharing for a little while and then share the slides. So what we are left with now is integration in the context of mutation testing. So we'll see that. Yeah. So we were at 9.4 and we discussed this particular one, wherein we discussed mutation testing with respect to other criteria, that is graph based and so on. Similarly, the last thing that is with respect to week 9 is this. So we'll see this one. This is for integration testing. Is the slide same? No, it's different. It's still named as mutation testing, but nonetheless, it is about integration. Okay. So we see this one. So in this, it says we focus on mutation testing for design integration in 2 parts. Okay. So it says using mutation testing for testing at the integration level. We'll think about it, what it means, without regard to object-oriented relationships. Now that we are kind of evolving that a little bit, right? So mutation testing we discuss in the context of programs only, right? We were mutating programs and getting mutants and killing those and all that, right? You saw that. But in that, there were no discussions about how object-oriented constructs are working, right? So for instance, you have this access modifiers or classes and class hierarchy, and then you have inheritance, polymorphism, and all those things were not considered, in that one. So that is one aspect that we can in some sense evolved this idea of mutation testing into, like adding object oriented concepts to that is one thing, right? So that is what it says, we considered it. So that is one possibility of thinking about mutation testing. The other is with regards to integration. So therefore it says two parts. In the first part, we are going to still discuss integration level testing, because that's what we have not discussed so far. We've just discussed program level mutation testing without object oriented relationships. In this case, we are going to discuss integration level, first of all, without object oriented relationships, and then moving forward, this second point says that we are going to test for problems involving inheritance, polymorphism, and dynamic binding, which basically means object oriented concepts. Okay, so that is the outline. So I might have discussed it briefly in one of the earlier live sessions, wherein I mentioned that integration mutation is also interface mutation, because what we are doing is basically, when you have a modular application, multiple modules, right? And those are communicating in the ideal case via means of interfaces, right? So what we do in integration mutation is basically test the connections, right? And that's what it says on the slide also. So therefore, we do mutation at the interface level or on the interfaces that are defined, right? So therefore, it is also called interface mutation. Okay, and it works by creating mutants on the connections between the components. I mean, basically, so most of the mutants are on method calls and are both calling and the called methods are considered. So it's like a caller callee kind of relationship, right? So you have this method which is calling something else, which is possibly residing in some other module, some other class, right? Now that object oriented also, but even without object oriented concept, it might be some other, some other module which is being called. Maybe it's a remote procedure call or some external library that is being called. Let's say, for example, when you call print, right? So that goes to a system call, right? and that system call then basically talks to the device driver that basically prints onto your graphics whatever that renderer is, and then it comes onto the monitor. So that is how print works, right? Even though it's a very basic call. So this kinds of modularity is always there, at all levels. So we are going to consider this. Okay, so what we can do then is basically there are a few things that we can do in this case. How can we mutate, right? So we're considering calls and responses in some sense. So you have this one place wherein you are making the call, as in you are calling one method that is residing somewhere else, we are assuming, and then you get the result back. So it's like the return value of that particular method is going to get returned to your caller function back, right? So, and the caller is basically from where the call is made, and the callee method is where the call is made, like the name of the method where it is, which we are trying to invoke. Okay, so that's the idea. So basically, there are few things that we can do in this case. It says you can change a calling method by modifying the value that are sent to the call method. So for example, the parameters, the arguments that are being given, right, into the call, we can change it. So I was calling something and then I modified the arguments and so on. So that is one thing. And yeah, and then we can change a calling method by modifying the call. This part we will have to elaborate a little bit. We'll see moving forward what this exactly means, like modifying the call. And then it says change a call method by modifying the values that enter and leave the method, leave a method. That is in some sense, you know, uh, maybe something else that is becoming part of the scope when the program goes there. So for example, you have external variables also, right? So some class level parameters that are defined. So when you enter a method, it is not just whatever has been passed by means of parameters to your methods. It's only also something which is external to that method, but within the same scope. Like for example, in the same class, you have this instance variables and so on, right? So string name, private strings, public strings, and so on. All these things are there, and then you can access that too, right? So we can modify those aspects as well. And the last thing is regarding the return statement. So we basically, whatever is returned, we make modifications there. So there are certain operators that then you apply on to achieve these things. As we have discussed, mutation operators allow us to do mutations that are valid and are compilable. Like the program that you get as a mutant can compile, and therefore you can test. So we have these mutation operators in this particular case. For interface mutation, we have integration parameter variable replacement, that is IVPR, and integration. So everything has an integration prefix to it, because of course that's what you're going to do in the context of integration. So we have parameter variable replacement, and this name is sort of it also hints as to what it does, right? So it says parameter variable replacement, which you can possibly understand that we are changing something in the parameter that are being passed to that. Similarly, you have unary operator insertion, which we have seen earlier also, without integration in some sense, right? And then we have parameter exchange, similarly method call deletion, and so on, and then return expression modification. So we'll see all this. So the first one is integration parameter variable replacement. It says each parameter in a method call. This is call, by the way. Okay, when you're calling, you call it, right? So you define something private void this method body is there, and then you have this other method from where you're calling this. So let's say that is called method A. So you call it like method A, and then you have parentheses around that, and then you maybe optionally pass parameters to that. So that is talking about that is the method call. Okay, and then what we are doing is that each parameter is being replaced by each other variable of compatible type in the current scope of the method call. Of course, from where you're calling that particular method, the callee method, right? It is also residing in some scope. Maybe you're calling it. So let's say there is this method in your class which is named as let's say create student. Let's say, right? And this method, and then from the main there are two methods. So there is main method also. So from the main method you're calling create student. Let's say, right? So in the main method there are other things also in that scope, and therefore you are having other integers maybe, or other other objects which are maybe of compatible types, which it accepts, which the called method accepts as parameters, maybe integers, right? So you can give some other integer also, right? So basically you're replacing that. Instead of passing that parameter, you are giving something else, but it says quite intuitively that it cannot accept incompatible type. So for example, if the call method accepts a string, then you cannot, let's say, pass some other object, an employee object to that, or something else like integer. You cannot pass a string and so on, right? So you have to convert it or cast it. That's a different thing. But in general, we are saying that until unless it is compatible, we cannot pass it. So this is understandable, right? In Java, for instance, you cannot do that. And similarly, so it says in object-oriented languages, this operator replaces primitive type variables as well as objects. So there are two things, right? If you remember, there are certain things which are primitive type variables. So for example, this pass by value, pass by reference in Java, right? So and those objects are generally passed by reference. So you're basically passing a reference and so on. In primitive types like integers and booleans and so on, those are passed by value. So that a copy of the value goes on and so on. So this is okay. But basically it says that in the context of object-oriented languages, since the parameters can be object also, like I'm accepting a student, I may be calculating a CGPA for the student, therefore I take a student object there, right? Student S. So then I can maybe change the student object to some other student and so on, right? That can happen. So both of these things are possible, and therefore I can do objects as well as primitive types in the context of object-oriented languages. And then we have integration unary operator insertion that basically says each expression in a method call is modified by inserting all possible unary operators in front and behind it. So this is possible in when the return is a type wherein it is possible to add unary operators. So let's say you are returning a Boolean value that is likely, right? So you are calling binary search from somewhere, right? And that binary search will return something like true or false, depending on whether. Uh, yeah, sure. I can. Let me zoom. You know.
Yeah, fine, sir.
Okay, thank you. So this one I was mentioning, right? So you have a return method call, and that returns something. So let's say there's this find method or binary search method which does something. There's this array, and it searches into that. If the element is found, then it says true. If it is not found, then it says false. So one possible unary operator that I can possibly insert then in that method call is possibly not, right? So not of find. So if find returns true, then not of find will become false and so on, right? So that is what happens. If it is returning false, then you do a not of that, and then it becomes true, right? So it flips that value. So basically that's the idea. Whatever unary operators are compatible, what you're doing is basically inserting in front and behind it. So maybe you'll see example for this one to make it more clear. Okay, and this one is slightly easier. It says integration parameter exchange. So earlier what we discussed was regarding the scope, right? So whatever available options you have in that particular scope, maybe you have several variables which are of compatible type, and then there is this method which accepts integers. So every integer in your scope you are replacing with that, right? Everything. However, this was parameter variable replacement. However, in the exchange, the same thing, right? This is parameter exchange. What we are doing is that in the same method call, so now we are doing replacement, limited replacement only within that. So for example, this order is changed, right? So A and B are there, right? So we are replacing with B and A and so on. It can be anything else. So for this particular case, it does not matter, right? Because max the order does not matter, but in certain cases it might, right? And therefore we flip it and see what happens and so on. So in this case, we are doing within the parameters only, and then exchanging from amongst those uh, parameters which are used in the original call. In the mutated call, we are having this, right? So we are not taking anything else from the scope. So let's say there was int c defined in the scope, but we are not taking that. However, in the case of replacement, what we will do is that if there is integer c is equal to something in the same scope, you can access that. Then you'll also do a max of c comma b or something like that, right? So that is the difference between the two. Please keep this one in mind. Okay, and this integration method called deletion says that each method call is deleted. So I mean, this was this is easier. So what we do is instead of calling that method, what you do is, because see, when you call a method, what happens? It goes somewhere, right, and it does something, and then it's going to return you something. So in the caller method, like the original, the caller method, it does not matter whether that method is being called or I am just getting a value, because after all, I'm going to get something, right, as a value returned back to me. So the idea then becomes that instead of actually calling that, I'm just removing that method call altogether. And instead of, because I need something then in place of that, because that method is no longer being called. So I need something. So then what I do, if that returns a value, so this cannot be applied to, let's say, void methods, right? So void methods do not return anything, then how can you replace? Maybe you have to do something else in that case if you delete, right? But if assuming that it returns something, so maybe it returns a boolean value. Let's say the find method was there, so it was returning true and false depending on whether some integer is found in a list or not, right? So maybe I deleted that altogether, find call, and instead of calling find, I'm just returning false in every case or returning true and so on, you know. So I can just replace it, like delete the method and replace it with a constant value. Okay, so that is what it says. The method call is replaced with an appropriate constant value. So it depends, right? If it is an integer, then you might replace it with something which is an integer and so on, so to ensure compatibility. And in Java, the default value should be used to method that returns value. Okay, so this is a recommendation, I think, or suggestion that they're giving in Java, that what we do, like the constant is, generally the default, that is. So for example, if integer, then it should be 0, right? Because that's the default. And if that is an object, because it can as well be an object, right? So what we do is basically create a new instance, empty instance of that. So if that was returning a student, let's say we are finding a student with the highest marks, then it returns a student object to me. So what I'm doing is that I'm removing that method call and just returning new student. So a blank, like initialized student object, right? So that's what we do. Okay, this part should be clear, I think. Any questions at this point? I think we are going to move to object-oriented concepts after this one. Yeah. All right. So I'm assuming it's okay. So this one is integration return expression modification. It says that yeah, each expression in each return statement is in a method is modified by applying the unary operator insertion or arithmetic operator replacement operators, right? So this is possible. So if, let's say, there was this addition method which was doing return a plus b, so instead of returning a plus b, you can just return a, right? So therefore, the effect is that that will affect something else, right? So I was calling this add method, calculator.add, and then I have changed that return statement to, instead of a plus b, I returned it with, let's say, a into b. So whatever was calling it, right, whichever other classes or methods were using that add method will get affected, right? So that's what we do. We just modify the return expression and then test accordingly. Okay, so now this is so that was in general, right? Because these things you can apply. So return expression modifications can be applied anywhere, right? Regardless of whether that is object oriented or not, because this arithmetic operator is general, right? You can apply in almost every programming language. Similarly, unary operators are also mostly available in all the languages, and therefore you can do that. It's not something which is specific to object oriented languages, right? You can do that. Similarly, this one also can be done, right? Because we are just replacing with the constant value. So this is possible. Similarly, we have parameter exchange, which is also possible regardless of this one. Only regarding this, it says that if you are doing object oriented methods, then if you are returning an object, then in that case you call new. But it does not mean that it is only applicable in object oriented contexts. Okay, without object oriented features also you can do this, right? It's still possible. Similarly, this is also possible, and this one is also possible, and lastly also this one. So everything that we discussed so far was applicable in both object oriented scenarios as well as non-object oriented languages. Okay, now what we are going to see now is going to be specific to object oriented languages. Okay, so it says several other keywords and constructs are added now when you consider object oriented languages like Java, right? So you have this language features that are relevant for integration testing of object oriented languages. That's what it says. So two things are possible now. One is that you do something which is at inter-method level, like between methods in the same class, right? And you can do something at an inter-class level also, like between different classes. Because again, this idea of module, though in general, one might consider it to be, class. So one class is another module from a different class. But this definition of a module is somewhat subjective, as when you, like, it's somewhat related to software engineering. At what level you're calling something a module? Maybe someone is calling a method also a module. That is possible, though unlikely. In general, we consider classes to be different modules, but nonetheless, you can do testing across methods also. So that is also some kind of an integration, right? So even though it's in the same class, maybe those two methods are not talking to each other properly, right? And in that case, you have to test the integration. Therefore, that is inter-method level. And similarly, inter-class is understandable, right? So there are two different classes. You're having interaction between the classes, and you have to do testing. So these are the two ways. So it says that these are the object-oriented concepts, but we are going to look at them again with respect to this integration testing. So it says encapsulation. I'll not go through all this in detail because I presume that all of you would have done Java in the diploma level, so you might remember. But nonetheless, if there are specific questions you might ask, I'll be happy to clear that. But in general, I'll just quickly go over the operators that are available in these cases. Okay, so one is encapsulation. The other is class inheritance, method overriding, variable hiding, class constructors. These are specific, not that to object-oriented languages only, right? Polymorphism, and lastly, overloading as well. Okay, and so before we move forward, one quick question. Can anyone point out the difference between overloading and overriding, if you remember?
Something with the same name of function, and another one is with parameters we will be.
Yeah, yeah,
I think
right,
so.
right. You're close actually. So overloading, what happens is that you have a class in that methods are there of same name, right? There is no restriction, you can have it. Only thing is that the order of the parameters or the types of the parameters might be different. So you have this add method, let's say in the calculator class. So I have this calculator class, and that we have an add method. So that add method can accept floats also, right? Or decimals. And then there is another add method which works for integers. Or let's say there is this add method which works with real numbers. So you have floats, for example, and on the other hand, you can have add method for complex numbers, but both can be named as add. When the caller calls it, depending on what parameters are being passed, the appropriate method will be called. So that is overloading, okay? Because that the method's name is same, you're just changing the parameters, or maybe extra parameters you're taking. In that case also, we'll consider that overloading. However, method overriding is that when a method is declared in one class and then you are inheriting from that, that is related to class inheritance, and then you are overriding the functionality of the super class, right? So, or the parent class. So that is called overriding. Okay, so we'll see. So encapsulation, again, it says that it's an abstraction mechanism to enforce information hiding, right? Everything. So in general, in a nutshell, what we say is that everything that is part of a specific class, that is meant to be part of the functionality of some class or a module, for instance, in general, should be encapsulated in that module only, and should not be part of other modules, or should not leak to other modules. Like information should not leak to other modules and so on. So for example, if you have a calculator class, for instance, it should not contain methods that are applicable for printer, let's say printer class. The printer class is a different thing. You can understand, right? That has its own dependencies and so on. Maybe it is doing something with the printer. However, you have a calculator class also, which is doing something, and then you cannot have a print method, let's say in the calculator class, for instance, right? So this is kind of an abstract example that I gave, but that's generally the idea. Okay, unnecessary dependence on the decisions in the implementation of the abstraction. Basically, everything is encapsulated very well into their own modules, right? So this idea of single responsibility principle, you might know possibly, is also there, right? So each class should be responsible for only one functionality, and that only does that, right? So it again reiterates the idea of encapsulation. Now, objects can restrict access to their memory variables and methods by other objects using encapsulation. So you have this access modifiers, right, as we call it. So you can have private, protected, public, and default. So for example, some things which are private to a particular class cannot be accessed into another class, and so on, right? Protected is when you have a direct inheritance. So you have a parent class, and then you create another class that, let's call it child class, and then you are inheriting from the parent class. Then all the protected methods of the parent class can be accessed by the child class. Okay, so that is only when you are doing inheritance, okay, or overriding, for instance. Private methods can still not be accessible. Similarly, and not only methods, private anything like private variables, private methods, or any other such thing which is marked as private. Similarly, protected is only direct, like direct inheritance, only when when that happens, you can access. Otherwise, you cannot. Public is of course public, so across classes you can access. And this default is special because this is something related to what packages are in Java. So you might know that there is this package also. Sometimes you also call it namespace in Java. You call it, right? So I don't recall exactly what the keyword was. The keyword was package itself, yeah. So you say package, and then there is this long domain like identifier. So you have this, com.example.application and so on, something like that, and that is called a package. So what then default says when you don't specify? So default is not a keyword though. Please keep this in mind. Okay, it might be there for the switch case default that is there, but in general it's not an access modifier, because if you don't specify that, so these things you can specify. Private you can specify, protected you can specify, public also you can specify. When you don't specify anything, it automatically goes back to defaults. So you don't have to explicitly say default. Okay, you might know that from Java also. So in general, what happens to default is whatever is part of the same package can, like whatever is belonging to the same package, can access that default uh, properties and methods. Okay, the default access is package. Like for example, if you don't specify anything, you're just doing void main and so on, right? You don't have a public, you don't have a private, you don't have a protected, then in that case it falls back to default. Okay, so this nicely summarizes the idea. So it says private can also be of course accessed in the same class. A package, of course, because it's like, this is like the most restrictive, and then you are kind of relaxing it a little bit. I would not say it should be package. I think protected comes first because that is direct inheritance, and then you have package, and then finally you have public. Okay, so of course what is accessible within same class is everything, right? So private is of course accessible within same class, and therefore every other thing also. Similarly, different class within the same package cannot, because it is private, right? Other things are okay because we have same package, right? So package also works. Protected cannot work because yeah, I mean it can access, but it's just that you have to have an direct inheritance. So that is a special case for protected, and public is public anyway, so that's okay. And similarly, you can have different package, but it's a subclass, yeah. So that is what when protected can access. So apparently, you don't, even if you don't have a subclass, you can still access it, possibly. Okay. So this part I need to check. If it is a non-subclass, yeah, if it's a non-subclass, then you cannot do, right? So it only says it for protected in a different package. But uh, what about same package but not subclass? That is not mentioned, right? Okay. But if it's the same package, then but it is not a subclass. Then in that case, I think protected would go to no. Okay, which is not mentioned here. It's okay. So you have different package, but it's a subclass. Then of course you can have protected, and similarly public is always accessible, right? So, and similarly you have a different package, but it's also not a subclass. Then of course even protected cannot work, right? But because for protected to work, it has to be exactly a subclass, right? It's like inheritance. Okay, this part should be okay. If there are any questions, please feel free to interrupt and ask in between. I'll be taking that as well. So this is about inheritance. All of you might know this one already because to some extent it's also there in Python, and in Java particularly it's there. So it says inherits variables and methods from its parent, all of its ancestors, right? So you have this parent class which is also inheriting from something, right? So you might know that in Java the highest class in some sense is the object class, because everything inherits from object, right? Therefore you always have toString or something like that. Some default methods are already there, right? That is because it inherits from object class. Okay, so that is like the super class in some sense, the highest super class. Anyway, so this is how it works. So you have this parent, and maybe it also inherits from something. So when you inherit a subclass, it is going to by default access all the ancestors. Okay, so that goes there automatically. It is not like multiple class inheritance. So there's this difference. What happens in multiple class inheritance is that you have a class, and then you are inheriting from one class, and then you are inheriting from another class which is not part of that line of inheritance. Okay, some different line of inheritance also, but you are doing something like class 1 comma, and then you are putting class 2 also, and so on. So that is not permissible in Java. Okay, however in some other languages it works. Like for example, I think in C#, that is one language from Microsoft, multiple class inheritance is supported, if I recall correctly. However, in Java, what happens is that you can do multiple class inheritance, but in a linear fashion, as in the superclass must inherit from its superclass and so on. So when you have a subclass which is going to inherit from that parent class, it is going to all by default access from all the inherit from all the ancestors. So that is possible. It's like linear inheritance. However, multiple class inheritance is not possible. Yeah, so every class has only one immediate parent, right? So that is what you have. And so the subclasses then can do something, right? So I in some sense inherit all the functionality that was given to me by the parent class. In that case, I can use them as defined. So there is this method. I'm not making any change. I'm not overriding it. I can just call it, right? And then it works. I can override maybe some functionality. I can modify from the parent. That is possible, right? So I'm doing some kind of a specialization in that case, right? So you have this generic class calculator, and then maybe you are having some scientific calculator that is inheriting from calculator class. That's a concrete example, right? And or it can hide the variables also. Like for example, some things are there in the parent class, but when the subclass inherits that, it removes that functionality. It cannot remove as such, but it hides it. Maybe makes it private or something like that, so that other classes cannot call it directly. That is also possible. We'll see this. And yeah, subclasses can also explicitly use their parents variable and methods using the super keyword. Like if you want to strictly call only the parents version of your method, assuming that one is declared, then in that case you can use the super keyword. That is basically used to refer to the parent class, right? So that's the idea. So these are the three things you have: method overriding, variable hiding, and class constructors also work in the same way, because you can, when you inherit a class, the constructors are also inherited. Okay. Okay, so what method overriding does is that it allows a method in a subclass to have the same name, arguments, and result. Everything is same. The signature, as we call it, is same. Okay, what is in a signature? The name, the arguments, and the return type. Okay, so if these things are matching, you say the signature is same. That's what signature means. So it says overriding allows subclasses to redefine inherited methods. Like for example, you can change the body of the method, the actual functionality, right? So it was doing something, but you changed the logic, maybe. But the name is same, the arguments are same, the result type is also same. So signature is same, but the implementation is changed. Okay, so that is what overriding is about. So this child class method has the same signature but a different implementation. So that is what overriding is. And variable hiding is basically, is achieved by defining a variable in the child class that has the same name and type of inherited variable. So what you can do, let's say I have this parent class in which some variable is defined. Let's call it a, right? So that may be public or something, right? Public integer a. I have it, and then I inherit. I make a subclass out of that parent class, and I have this same name of the variable a, and then I make it private. So private integer a. So what happens as a result is that when other callers will try to access that variable, saying that this child class name, so child class some name dot, and then you have a, it will basically complain saying that that is private, you cannot access it, even though in the parent class it was public, so everyone could access it. However, now I have made a subclass which cannot directly access the parent version of that. So in effect, what happens is that the inherited variable is hidden now. Like it cannot be accessed because you made it private and so on. There are other ways of doing variable hiding, but that's generally the idea. Okay. And a constructor in a class is a special type of subroutine called to create an object. You might know already what this does, and basically allocates memory for the new object and so on. And it accepts arguments to in some sense initialize the object, right? And yeah, so there's some differences as to how a constructor gets inherited with respect to other methods, other general methods, because constructor is slightly special, right? So you have to call super keyword. You cannot inherit a constructor without calling the super keyword. So what super keyword does is that it will call the instructor of the parent class. So you have to necessarily call it, okay? And this call is specific to Java at least. And it says this call must be the first statement in the derived class constructor. And yeah, so when you are inheriting the constructor, two things must take place. First, you have to necessarily call the parent constructor by using the super keyword, calling super, and that should be the first statement. That is a necessity. Secondly, the parameter list must match the parameters in the argument list of the parent constructor. So the parameters, the signature of the constructor must be the same in some sense. Okay. And in the signature of the constructor, you only have the parameter list and the name of the class. You cannot have uh, a return type, right? Because by default returns an instance of that particular class. Okay. So in effect, basically your parameter list must match. So two things. First is you have to call this parent constructor, and the parameter list must be same, must match. And then you can do something else also, that's possible. You can override the constructor, that's still possible. However, the parameter list must be same. And then there is something known as polymorphism. Some of you may know that already. And it says that there are two ways of doing this. So one is with regards to attributes, and the second is methods. So it says they both use dynamic binding. Now a little bit of background here. So why it's called dynamic is because what happens is the runtime type. You understand what compile time and runtime are? So compile time is when the code is being compiled, right? So it's not running, it's not in memory, it's not a process yet, it's not running on your computer. We are just compiling the program. And then there is this runtime wherein your program is actually running. So I'm running this Google Chrome browser, right? Currently, so this instance is in its runtime, right? It's running. So there is this memory allocation, RAM, heap, stack, and so on. All these things are there. So what happens in dynamic binding is when you so all these things is possible, right? Inheritance, and then you kind of make an instance, make an instance of a child class using parents reference, right? So I can have, let's say I have this calculator and a scientific calculator. So what I can do is something like this. So calculator C is equal to new scientific calculator, which is a child class. So I'm using the reference of a parent to invoke or to create an instance of the child class. That is still possible because both are compatible with each other, right? So therefore it says one is a declared type. when you are when you are doing this constructor, when you're doing new this thing, whatever the class is, and then parenthesis, that's the declared type, which reference is there when you are taking that in. And an actual type when in the runtime what it becomes, right? So so that is how polymorphism works. It basically changes its shape and form at the runtime. Maybe in the compile time it's something else, right? So maybe we don't have an example here, I see, but maybe an example would have helped in this regard. Yeah. But the idea is general. I mean, like, because you can have a parent class and a child class, you can have a parent class reference to initialize the child class, also child class object. So the reference is the of parent, the actual object is that of the child class, and when you run it only, uh, then the runtime knows that what is the actual type, right? That's how polymorphism works. And yeah, it can take various types, right? Depending on the runtime, what it takes, what is the current type of that, because it can change. Therefore, the name polymorphic. Okay, and at any location in the program, the type of the reference can be in different executions, right? And a polymorphic method can accept parameters of different types by having a parameter that is declared of type object. Yeah, similar to object, right? So let's say, for example, that's a very good example. So what happens is that I have this some method that is doing something, and what I'm doing is that I'm accepting an object there. Okay, so now what can happen? Because it is object and everything is an object, I can pass an integer, I can also pass a string, I can also pass some other reference to an object like a student object, employee object, and all these things I can pass because it is accepting object. So basically it accepts everything. So how do I know what is the actual type of the object then? The parameter, when I take it, I don't know. In the runtime, I'll know what is being passed to it, right? Then only I would come to know what exactly was passed when I run it. Otherwise, in the compile time, I don't know because that is just object. So I really don't know what that is. That is one example of polymorphic method. Okay? And that is used to implement something known as type abstraction. Like, you can abstract different types and make the method take on, or the object take on different forms as in when the program runs, depending on the needs and so on. And this is a very useful feature, by the way, and this is extensively used in complex programs you see. Okay, and then this one is overloading, of which I think I asked the question and somebody answered also. That is of the same, this is a method of the same name, a different yeah, it can be as well constructor also. Overloading is applicable to constructors as well, right, in the same class. So it must have different signatures, meaning it can have a different return type, it can have a different list of arguments, or but it has to have same name, right? So there are three things in a signature. You have a name, you have a list of arguments, the parameters that it accepts, and the return type. So the name of course must be same, then only you do overloading, right? So that is okay. Now we are left with the return type and the list of arguments. So it should differ. Okay. So you can have a different list of arguments that you accept, and it can have a different return type also. So that is overloading, and that is different from overriding is what I asked earlier. Okay, so it says former occurs with two methods in the same class, right? So this former meaning overloading, okay, because you have two methods which are of same name, different arguments, that is within the same class. However, overriding is between a class and one of its descendants. So you have this parent class, and then the child class is going to modify the behavior of the inherited method. So that is overriding. Okay, and then okay, quite long one. So it basically says. Instance and class variables are associated with a class. So certain things are static also, right? So you can directly access it without having an instance, for instance. So you have this constants that you declare on top of your classes, right? So let's say pi, I want to declare pi, the constant pi. So I can say public static uh, this integer or float pi 3.14 or 15 3.14159, how many ever digits I wish to have. Right, then that is static. So without creating an instance of, let's say, the calculator class, I can still access it. So instead of using the parenthesis, how do you access that? You just do calculator dot, just the name, and then dot without the parentheses, and then you can still access that, right? It's like accessing constants. So there are static variables as well as static methods that is also possible, and you can directly call it. Okay, and whereas instance methods are, on the other hand, are some things which necessarily require you to have an instance. You cannot statically call it, right? You have to have an instance. For example, if I am having a student class which gets the result, which calculates the marks, which gets the total marks of that student, then that cannot be a class method, right? Because for every student, the marks, the individual subject marks might be different. So to calculate the total marks, the final marks, I need to have some instance, right, of a particular student, and then I can calculate the total marks. It cannot be static, for instance, right? Because the marks differ across instances of the students. Similarly, right, so other objects also. So therefore you need that. So you have an instance method in that case. That cannot be static. Okay, for example. Yeah, that's what I said. So instance variables belong to an object of this of a class. Every instance of a class has its own copy of the variable. So across different instances of students, the marks would differ, right? So physics marks, chemistry marks, and mathematics marks will actually differ across student instances. However, so if you have something static, let's say the pi constant, and that is static, and therefore across all calculators, you have the constant pi as same, right? That's what happens. And similarly, changes made to instance variable don't reflect in others. So if you change one student's marks, then it is not going to reflect into other student object, right? Of course. And that's what you have. And yeah, so instance variables are declared at class level because you have to have an instance of the class before you can access all those methods and variables. And class variables are declared with static. So it's like at the scope of the class and not an instance, because without having an instance also you can access it. Okay. So similar to what example I gave, like the pi constant and so on. There are other constants that are generally constants are declared in this way. However, there are other methods also which are generally declared this way. So it's okay. I think even the main method that is there in Java, that is also static because that is the first method to run. So it needs to be static because before that you don't have an instance of your, because the program is not running. So how can you have an instance? And therefore you have that method as static, which starts the program, and then you start running the rest of the things, right? So the main method, for instance, is static. And similarly, you have local variables that are declared within method. This one we understand, right? Within the scope of a particular method, local variables. Okay, so mutation operators. Then so now with this in mind, like this was a little bit of background about object oriented itself, concepts itself. So you might be able to understand it without this explanation as well. But I just wanted to mention it so that others could benefit as well later on, because this is being recorded anyway. So now This is object oriented. Now we have mutation operators again, because if we want to do integration testing by means of doing mutation, you need to use mutation operators, and therefore you are having this. So all these object oriented features that we've seen, we'll see some operators that allow us to do test for these things, right? Okay. So one is access modifier change, right? So this one is easy. We discussed in detail, right? This private, public, protected, and default. So access modifier change, what it does basically changes the access level. So let's say you have something as private, you make it public, and then you see what effect it has, right? So basically, what it allows us to achieve, it allows us to achieve correct accessibility, ensuring that the programmer or the developer actually has given correct access modifiers. So mistakenly, someone should not make something which is meant to be private as public, because then other methods can access that. Other classes or other modules can, access that, and maybe do some error, cause some errors. Therefore, we have to ensure that the accessibility given by the programmer is correct, and we check it by means of this particular operator. Okay. And similarly, you have yeah, it says AMC created mutants can be killed only if new access level denies access to. So what do you do? So how can you do that? So for example, if something was meant to be public, right? So what you do is you modify that and make it private. Now it cannot be accessed, right? So your test case will fail basically, because that is no longer accessible, right? So that's how you can kill that particular mutant, because access level is changed now. Maybe something was package like default access modifier, you make it public, and then you are able to access it somewhere else also, right? So in general, to kill it, you have to have something which denies. Otherwise, so say for example, if something was private, you make it public, it is still accessible, right? So in that way, mutant cannot be killed. So you need to have something which is a different access level, which can basically deny access, and then it kills that. I think there is a message. Mm. Oh yeah, sure. So we will try to wrap up by 9. I think there's few slides more to go. I was hoping we could just wrap up with this one today, um, so that we can continue on the next one, like for object oriented integration, which is part of week 10 on Friday on, like from Friday onwards. But uh, if we wish, we can wrap it up today and then maybe continue from there onwards in the next one as well. So let's see. We'll have how much? Yeah, quite a few things to discuss, and you have to maybe remember at least the names and the definitions from this one for the purpose of the exam as well, because this can be asked. Okay. So yeah, sure. So we have discussed object oriented concepts, and what remains now is are the operators to be discussed. Okay. So if you wish, we can discuss this in the upcoming class also, because we are already out of time. Okay. So the next class is on Friday, right?
Yes,
Must
sir.
have been
Sir,
scheduled. Yeah.
if you want, we can start early also.
Yeah, starting early is possible. Yes, that's possible, but I'll have to check, because
Yeah, yeah. No, no. If you want to. It's fine.
yeah. Yeah, sure. I'll check, though it is unlikely that it can happen, because there is this scheduled sessions are usually fixed, right? So we cannot,
Okay.
yeah, cannot modify. But it's okay. So what remains now from there onwards, just to quickly summarize, is are the so we discussed the integration of the object oriented features, right? And accordingly, we are having these new mutation operators which were not there earlier, and we are going to discuss these moving forward, and then we see how we can apply this uh, to do object oriented integration testing. So that's the idea. And so what we can do is we can discuss these operators in conjunction with an example, possibly from the next one also, that is part of week 10. Okay. So this happens to be a uh, long one, but nonetheless it's useful, right? Because some interesting operators are being discussed here, and there are chances that there might be questions around this also in the exam. Okay. So yeah, sure. We'll discuss that, though it is likely that it will be 8 p.m. onwards only on Friday. But in case of any change, we'll keep you updated. Okay. So that is all there is to it. And Any more questions before we can close for today?
Nothing, sir.
All right. Okay. Thank you so much for being here. And yeah, we hope to see you in the next one also.
Thank you, sir.
Thank you.